in millimeters below the top of the active fuel, or it's below the top of the fuel. And yesterday I showed you pictures of the fuel element. It's a very long element. They're basically 3.8 meters tall. Okay, so these, when it shows 1,700 millimeters below the top, that means it's about halfway down the fuel bundle. And our understanding is, and all of our indications indicate this, is that the water is steaming there at that level, and so the steam rises, and that steam actually helps cool the fuel in the upper part of the core. And so this shows some variations from March 15th through late yesterday on the 17th. I should mention that just before I went into the briefing with the member states, I received information from the Incident and Emergency Center that was telling me that the latest values that they're getting are pretty much in line with these, that there's no major changes. So I don't expect any big drop-offs from the next readings. So this shows how the level has varied between 1,700 millimeters and 1,800 millimeters, or, if you would, between 17 and 18 centimeters. So it's not a lot of a change. These things are the way they're plotted. It helps us see the changes, but you shouldn't see these as major fluctuations. These are actually very minor fluctuations. So that's the water level. This is the reactor vessel pressure that we were seeing from, we had data back to the 14th, and these are two different monitors that are monitoring the pressures. And it's not unusual to see them not to be exactly the same. It's the reason you have more than one monitor, so that you can try and validate. You can see on the 14th they diverged quite a bit, but over the next 2 days they came back into kind of convergence, and now they're tracking pretty much along with each other. And these are the units on the left-hand side are in bars, and one bar is equal to one standard atmospheric pressure, and so these are in pressures above the standard atmospheric pressure. I wanted to make a statement is we don't have data for the primary containment vessel for Unit 1. I do have it for the next two, for 2 and 3, but so I don't have containment pressure for those, for Unit 1. This is the water level for Unit 2. It's slightly higher, again, because we're using negative numbers, just to try and confuse us all, but it's the way we look at the levels. And the reason that is typically the level in the reactor vessel is several meters above the fuel, and so those are the positive numbers, and that's what we're used to seeing. And they don't want it to go below zero, and in this case it has. But so we're fluctuating between, if you would, 14 centimeters or 1,400 millimeters is about the standard, and it varies around there a couple centimeters one way or the other, but fairly constant. And this is because they've been able to continue to pump in the seawater into the vessel. For the Unit 2, I probably have the most dramatic changes from both the reactor vessel pressure and the containment vessel pressure. In this case, this is when they depressurize the reactor vessel starting back on the 14th, to be able to reduce the pressure so they could pump using the seawater pumps in. And the values in blue there at the beginning, we don't think are really real values. But again, starting about on the beginning of early in the 16th, you see that the vessel level indications are starting to track very much together and are slightly increasing as they go on. I mean the pressures, I'm sorry, I said levels. As the pressure in the reactor vessel goes down, when you relieve the pressure in the vessel, it goes into the reactor containment pressure vessel.